Here's an example in which we find for an angle, we find the secant, cosecant, tangent, and cotangent. What I want to do is make this problem a little more interesting. So 13, let's do it for 13 pi over 4. So how do we, for 13 pi over 4, how do we find these other trig functions, secant, cosecant, tangent, and cotangent? Well, first off, let me give you some definitions for those. So secant, so here let me just put in a sheet right here and give you the definitions. So we know that the sine and the cosine, that's equal to the y value. Cosine is equal to the x value on the unit circle. Say on the unit circle. On the unit circle. Tangent is the sine over the cosine. Now the other three trig functions, cosecant, in fact, why don't I write out the whole word here. Cosecant, which is abbreviated CSC, and secant, which is abbreviated SEC, and then cotangent. So what are those? Well, these are, here, let me do that a little better. These are the reciprocal functions. They're upside down. So they're the reciprocals. So this is going to be 1 over the sine. This one will be 1 over the cosine. So we have the sine, and then the cosecant is 1 over the sine. We have the cosine, which is the x, and the secant, which is 1 over the cosine, and then the tangent, which is sine over cosine, and the cotangent, which is the upside down of that, cosine over sine. So the first three trig functions, sine, cosine, and tangent, and then the other three are just the upside downs of the first three. They're the reciprocals. And even tangent actually just comes from sine and cosine. So what I want you to see here is that all the trig functions really just come from sine and cosine, don't they? It's all about sine and cosine. Really, all of trigonometry is about sine and cosine, because the sine is the y value on the unit circle, and the cosine is the x value on the unit circle, and then all the other trig functions are just made out of sine and cosine. They're just Johnny-come-latelys. They're not originals, right? They're all just made out of sine and cosine. Tangent is sine over cosine, and then cosecant is upside down of sine, secant is upside down of cosine, and cotangent is upside down of tangent, meaning it's cosine over sine. So there's only two originals, sine and cosine. The other four come from sine and cosine. Okay, so that means the secant here is going to be 1 over cosine. So then we have to go find cosine for 13 pi over 4. Now the trick about 13 pi over 4, in fact, actually I should probably just do it right over here. 13 pi over 4 is that it's more than 2 pi. How do I know? Because 2 pi is 8 pi over 4. Let me show you how I got that. Because if you want to take 2 pi is all the way around, isn't it? 2 pi, here's the unit circle. 2 pi is all the way around. That's 360 degrees, right? Pi is halfway around, 180 degrees. 2 pi is all the way around, 360 degrees. So my point is that 13 pi over 4 is more than all the way around. Let's prove it. If 2 pi is 2 pi over 1, multiply top and bottom by 4 to get a common denominator so that we can compare it with this, and you get 8 pi over 4, right? That's the same as 2 pi, isn't it? Right? 8 divided by 4 is just 2. So I'm not going to go back to 2 pi. I just want you to know that's the same as 2 pi. So 13 pi over 4 is clearly more than 8 pi over 4. So it's more than 2, and this is equal to 2 pi. So that this is more than 2 pi. It's more than the whole way around. So 13 pi over 4 is all the way around the unit circle and then some. isn't it? Well, let's find the and then some. So let's take the 13 pi over 4 and just subtract this, which is a fancy 2 pi, 8 pi over 4, leaves us with, let me make that a little better, 5 pi over 4. This is what's left, 5 pi over 4. So 13 pi over 4 goes all the way around and then 5 pi over 4 more, doesn't it? Do you understand what I'm saying there? So 13 pi over 4, take away a full rotation, leaves 5 pi over 4. So if you go all the way around, that's 2 pi, and you go 5 pi over 4 more, that's 13 pi over 4. So let's go do that. Let's go find that. So really, 13 pi over 4 is going to end in the same place as 5 pi over 4. They're coterminal. They end in the same place because 13 pi over 4 is all the way around a whole 2 pi. Take out the 2 pi and you're left with 5 pi over 4. So let's just go find 5 pi over 4. Where, oh where, is 5 pi over 4? It's actually right here, isn't it? There's 5 pi over 4, 225 degrees, and here's the cosine, here's the sine. Remember the x for all these, cosine, sine, cosine, sine, cosine, sine, etc. The x is always cosine, the sine is always y. They're both the same, it turns out. They're both negative root 2 over 2. So therefore, the cosine is negative root 2 over 2, and the sine also is negative root 2 over 2 at 5 pi over 4, which is the same as 13 pi over 4. So the secant, let's answer the question now. So the secant is 1 over the cosine, so it's 1 over, well, so it's the upside down. How about we do that? It's just the upside down of this cosine. So just flip it over, and you get negative 2 on the top, the root goes to the bottom. We flip it upside down. Now you can't leave a root on the bottom, so you have to multiply top and bottom by root 2. And so what do you get? Negative 2 root 2 over plane 2. Do you see that? Square root 2 times square root 2 is, let me do that a little better, is the square root of 4, which is 2. See what happened down there? I multiplied the top and the bottom here by square root of 2, top and bottom. And so that made 2 root 2 on the top, and on the bottom, root 4, root 2 times root 2 made root 4, which is plane 2. See how this 2 was an outsider? So he stayed outside, whereas both these 2's are inside the root, so they multiplied together inside the root. Make square root of 4, which is just 2. And then these cancel, don't they? So when all is said and done, the secant is negative root 2. Let me make that negative a little more clear. There we go. Let's try the cosecant. Cosecant is upside down of the sine. If you look back at the definitions, cosecant is upside down of the sine. See, secant was upside down of the cosine. So upside down of the sine, so we got to take the sine and flip it. So that means the same thing, doesn't it? I'm just going to jump to the answer. That's going to be negative root 2 also. It's the same answer. Oops. Let me try to do that one a little better. There we go. All right. Now let's go to the tangent. So for the tangent, that is sine, whoops. That is sine over cosine. So what's the sine up here? Negative root 2 over 2 over the cosine, which is the same thing, negative root 2 over 2. So that's just 1. Isn't it? The same thing divided by itself is 1. Now what's cotangent? Well, it's cotangent is upside down. If we go back down here, cotangent is upside down of tangent, so it's cosine over sine. Cosine over sine. So it's negative root 2 over 2 over negative root 2 over 2. So it also is 1. Like that. So there we go. We found all the trig functions, all the ones other than sine and cosine, by starting with sine and cosine. We got sine and cosine from the unit circle by realizing that 13 pi over 4, if you is more than 2 pi. So if you subtract 2 pi, which is 8 pi over 4, if you take out that extra rotation, you get down to 5 pi over 4. And so we just looked on the unit circle. It's all about having this unit circle in your notes on the homework and the exams. We found 5 pi over 4 right there, and the cosine and the sine, brought those back, cosine and sine, and then we went through the definitions, which are right here. Make sure you know these definitions, have them in your notes, that cosecant is 1 over sine, secant is 1 over cosine, tangent is sine over cosine, and cotan is upside down to that, cosine over sine. There we go.